Hello, Chemistry. Mr. McKee here, and we are kicking off our 7th and final unit of the year, which is titled Stoichiometry. So we should define what stoichiometry is first. It is the branch of chemistry that uses balanced chemical equations to predict quantities of reactants or products. So this unit is still going to be important to be able to balance equations and understand what they're communicating. So make sure that you are up to snuff on those particular skills. We're going to be emphasizing the use of mole ratios. We'll talk about that here in a minute. And basically, this is our unit in a very small nutshell here. We're going to begin by converting from moles to moles in products and reactants. Then we're going to learn how to convert from moles to mass. And finally, mass to mass. And this is going to be similar to stuff we've done throughout the year, but a little bit different. And this is really sort of the fundamentals of chemistry. If you're a pharmacologist and you're making certain medicines, this is the science and the math that you're going to use to accomplish that. So let's jump right in to our first application here, which is converting from moles to moles of another chemical. And we'll jump right into the example. This is the first example from your booklet. And it says how many moles of O2 are needed to produce 5.2 moles of PbO. So the first thing I recommend is underlining the important information in the question. So what we're interested in is moles of O2, and we've been given moles of PbO, lead oxide. So now we look at the equation down here, and I recommend you circle the important parts of the equation, the parts that we're going to be using. So we've been given moles of PbO, so there's that, and we're trying to figure out moles of oxygen. So we want to know how many moles of the reactant oxygen we're going to need to produce that many moles of the product, lead oxide. So for this particular question, at least, you can ignore these two quantities. Now, I could ask you about them in another question, so you probably shouldn't cross them out in your booklet, but at least for this example, we can ignore those. And we're only interested in the relationship between oxygen and lead oxide. So the starting number, as always, is the thing that you've been given in the question. So that is 5.2 moles of PbO. That goes in that space. And the ending unit is what we're trying to figure out, and that is going to be moles of oxygen. The relationship between the two we are going to get from the balanced chemical equation, and it does need to be balanced for this relationship to be correct. This one is. So we're going to focus in on the coefficients, and our relationship is that for every 3 moles of oxygen, we're going to have 2 moles of lead oxide. So we have a 3-to-2 mole ratio, and that's our conversion factor, and that's what we're going to plug into the train tracks down below. So just like we've done all year, we're going to put the starting number in unit into this place, 5.2 moles of PbO. And we're going to arrange my conversion factor so that I can cancel that out. So we're going to put moles of PbO on the bottom, and we're going to put the thing that we're converting to on top, which is moles of oxygen. And now I can plug the numbers in. So for every 2 moles of PbO, I've got 3 moles of oxygen. This enables us to cancel out moles of PbO, and it leaves us with moles of O2 in our answer, which was the objective. These should always be the same. Okay, lastly, I'm going to take and crunch the numbers here in the train tracks. So I'm going to take 5.2 times 3 divided by 2. So I'm going to times on top and divide down. Times on top and divide down, and then we only hit enter once. So again, it's 5.2 times 3 divided by 2, and when I do that, I get 7.8 moles of oxygen. So we just figured out that in order to make 5.2 moles of PbO, lead oxide, it is going to require 7.8 moles of oxygen, O2. So pause the video and give the U-try a try. Welcome back. So for the U-try, we're using the same chemical equation, but we are asking about different parts of the equation. So again, it's really critical to read the question carefully, and I suggest you underline the important information. So we are trying to find the number of moles of PbS this time, and we've been given the moles of oxygen. So the parts of the equation that we're interested in this time, still oxygen, and we want to know how many moles of PbS are going to react with 2.4 moles of oxygen. So in this case, we're interested in both of the reactants. So for the purposes of this particular question, we can ignore those parts of the equation. So I'm going to put 2.4 here, because that is the number that I was given. And the thing I'm trying to figure out is moles of PbS. The relationship between the two, again, I get by looking at the coefficients. So for every 2 moles of PbS, I'm going to have 3 moles of oxygen. So my starting number in the unit goes where it has all year. 2.4 moles of O2 here. And I'm going to multiply by my conversion factor, and I want to put moles of O2 on the bottom, so I'm going to have 3 moles of O2 here. That enables me to cancel out moles of O2 and convert to moles of PbS. So again, I can cancel out those units because they appear on both the top and the bottom. That leaves me with my answer in units of moles of PbS, which is the goal. Again, those should always be the same. So the last step is I times on top and divide down. So I take 2.4 times 2 divided by 3, and then I hit enter, and I get 1.6 moles of PbS. So I just figured out that if I'm going to use 2.4 moles of oxygen, I would need to use 1.6 moles of PbS along with it. All right, good luck on the practice problems. Remember that the answers have been given to you in parentheses, so make sure you get the right answer. Have a great day.